Okay, hi guys. So in this lecture, we'll be seeing equilibrium constant from thermodynamics approach. So let's get started. Thermodynamics approach. So just on a note basis, we can write that if reaction takes place at non-standard states, then at equilibrium delta Rg is equals to 0. Then at equilibrium delta Rg is equals to 0. Okay. And then for endothermic reactions, delta Rh is positive. Hence, we can write that delta Rg naught would be equals to minus RT ln K equivalent. We are talking about the equivalence point, and also delta Rg naught would be equals to delta Rh naught minus T delta Rs naught. This is the second equation. So let's substitute the value of delta Rg naught from first equation to the second equation. So we'll be getting minus RT ln K equivalent as delta Rh naught minus T delta Rs naught. So we can write that ln of K equivalent would be equals to delta Rs naught divided by R minus delta Rh naught divided by RT. Okay. Or we can also write this in terms of log, which would be equals to delta Rs naught divided by 2.303 R minus delta Rh naught divided by 2.303 RT. Okay. Next, for endothermic reactions, we would have the graph of ln K with respect to 1 upon T, which is 1 upon temperature. That would be equals to, this is y equals to, rather C minus mx. 1 upon T is x, so we can write this graph would be something like this. Okay. So next, for exothermic reactions, we would have delta Rh not as negative, so that would make this term positive. So we would have y equals to C plus mx. Here we are talking about the mod of delta Rh naught, so it would be positive here. So the slope would be positive and the graph would be upward trending. We have ln K and 1 upon T here. So this would be something like this, where the intercept would be delta Rs naught upon R and the slope would be equals to delta Rh naught upon R. Okay. Next, let's say at temperature T1 we have K1, which is equilibrium constant at temperature T1, and T2 is the temperature where we have K2 as our equilibrium constant. Okay, so we have some assumption that, let's say, delta RH naught and delta RS naught both are temperature independent from T1 to T2. So we can write that ln K1 would be equals to delta R S naught divided by R minus delta R H naught divided by RT1. This would be the first equation, and the second equation would be ln K2 would be equals to delta R S naught divided by R minus delta R H naught divided by RT2. This is the second equation. Combining both the equation, we would be getting, let's say we take the difference of first from second, so ln K2 upon K1 would be equals to delta R H naught divided by R 1 upon T1 minus 1 upon T2. Okay, so this is a very important result which you should remember. Many questions will be asked in JEE level and JEE level competitive examinations, so please remember this. So with this we come to the end of this lecture. In the next lecture we will be seeing equilibrium constant from kinetic approach. So till then, good luck and goodbye.